All right, Math 2 students, here we are going to try and graph the absolute value graph of absolute value of x minus 1. Okay, so what we know from class, we know this is going to be a V-shaped graph, but where exactly is it located? That's what we need to figure out. So you might be thinking, okay, this has some sort of shift. How do you figure that shift out? And that's what I'm here to help you out with. So, okay, so let's figure out the shift first. So I'm going to need to do some work on the side here, so I'm going to put a little post-it note over here. What's inside here, what you want to do is take what's inside and set it equal to 0. Okay, so if you set it equal to 0 and then solve this, that will tell us how far it switched. So there's not much to do to solve this. You're going to add 1 to both sides. That cancels out, and you get x equals 1. This is important because this tells us where it's shifted to, which will also be the line of symmetry. Okay, so x equals 1 is our line of symmetry. Keep that in mind. Let's move this up. Now we can go back to the graph. And x equals 1 is right here, and it's all the way up and down that line. And down. So there's your line of symmetry. Okay. Next thing. The v is going to be somewhere on here, but let's say you don't know exactly where. That's where a table of values comes in. Okay. So let's go ahead and plug in 1 as our line of symmetry, so we'll definitely want 1. And we'll want a couple points on this side, so 2 and 3. And a couple points on this side, so like 0 and -1. All right. So let's go ahead and we can start with any one of them. If you plugged in, let's start with a -1. If you plug in -1 here, you get absolute value of -1 minus 1, which is absolute value of -2, which is 2. So -1 gave us a 2. That's 1 point. So go across -1 and up 2. That's 1 point. If you plug in 0 in here, you get absolute value of 0 minus 1, which is absolute value of -1, which will give you just 1. These are absolute value bars. As you can tell, it's kind of hard to fit all this stuff in here. So usually you're going to want to use your notebooks or some other scratch paper to help figure that out. That's our next point, 0, 1. And then next, let's plug in 1. Absolute value of 1 minus 1 would be absolute value of 0, which is just 0. So there's your point. Now we have the left side of the graph. Now we still need the right side because we need to know what it does on the right side. Plug in 2. Absolute value of 2 minus 1 is absolute value of 1, which is 1. Next, we'll plug in 3. Absolute value of 3 minus 1. So that's going to give you absolute value of 2, which is just 2. So go across 3 and up 2. So each one of these is a point. 3, 2, 2, 1, 1, 0, 0, 1, and -1, 2. Each time you plug in a point, each time you plug in an x value, you're getting a point. So let's go ahead and do that, and then we need to graph it and connect it with a nice straight line. So these all, on this homework, they should all be V's. You should get a V-shaped graph, and if your table comes out not V, then something went wrong with the table. The key thing we're looking at is what's the shape of the V, and where's that vertex of the V. And if you do a couple points, it should come out nice like this. Okay, the rest of the front side is very much like that, and you probably finished that already. Well, let's flip to the back side. This gets a little more tricky. That's what I want to help you out with. So for this one, what we're going to do is, same sort of method. We're going to start by cover this up, and take what's inside here, whatever's inside, set it equal to 0. And that's going to be our line of symmetry. And that's key for these types of graphs. So got to be able to solve that. To solve this, go -2, -2. Those cancel. You'll end up with 2x equals -2. Solve that, you get x equals -1. That's your line of symmetry. That's where we're going to be focusing for our table of values. Just go ahead and take that -1. Let's remove that. And on the graph here, right at -1, all the way up and down, you put a dashed line. Some students find it helpful also to use a highlighter and do that. Whatever makes it stand out, there you go. Now you know where the line of symmetry is. And why that's important to do first is because with that, then you can do your table of values and know exactly what to do for your table of values. So this time I'm going to do this so I have plenty of room. So for my table of values, -1 is going to be one of the points. And we have to try a couple points on this side and a couple points on that side. So -1, another point on this side would be 0. Another point might be 1. And then let's try a couple points on this side, -2 and -3. Okay, there's going to be more calculations for this, so we got to go a little bit slow. So when we plug -3 into here, we get -2 absolute value, 2 times -3 plus 2 plus 4. Those are my absolute value bars. So absolute value bars, like parentheses, you got to do everything inside first. -2. This will give us -6 plus 2 plus 4. Again, clean up everything inside the absolute value. -2 absolute value. This will give us -4 plus 4. Next, we have the absolute value. We got to get rid of that. -2 absolute value of -4 will become just 4. So -2 times 4 would be -8 plus 4, which is -4. -3, -4. All that work to get that 1 point. So let's go -3 and -4. That's 1 point. Alrighty. Let's run through that again with the next point. Let's plug in -2 into here. That'd be -2 absolute value 2 plus 2 plus 4. So I've copied the whole equation, and then we're going to replace that with a -2 for x. And let's simplify this thing. -2. Do inside the absolute value bars, this is going to give us -4 plus 2 plus 4. Keep on working inside the absolute value bars. This plus this gives you -2. Now we've got everything done inside. So absolute value of -2 is 2 plus 4. And keep on going. Now we have multiplication. 2 times 2. We got -4 plus 4. Which finally will be, whoops, there we go. -4 plus 4, which would be 0. So that point is now 0. So across -2 and up 0, so that'd be a point right there. And let's do the last point. All right, let's cover that up. So when we plug in -1 into here, we get -2 absolute value 2 times -1 plus 2 absolute value bar plus 4. So -2 absolute value bar, -2 times a -1 would be -2 plus 2 plus 4. Again, we do everything inside first. 2. This whole thing right here down just gives us 0, which is kind of nice. So -2 times the absolute value of 0 would be a big 0 plus 4. And 0 plus 4 would just be 4. Alright, so that's how we've generated 3 points. Took a little bit of work here, but we got our points, -1 and 4. And that's half our graph. And make it nice and straight, it looks like that. Now the other thing is, this is a line of symmetry. So we can shortcut this. If we've done this much work, the other points will be the same. If it's got a point on this side, it's got an equal point on that side. So if you got a point at -1, you'll also have a point, sorry, at -2, that's 1 unit over from the line. You'll also have an opposite point on this side. If you got this point here, you'll have a mirror image or an opposite point on that side. And we could have found these by finishing up the table of values. But if you know you did it correct, that's the reason for the line of symmetry we started with. That's how we're going to graph it. Okay, so finally, your steps. One, find line of symmetry. 2, you make a table of values with points on left and the right of line of symmetry. So that's why you need the line of symmetry. You need to go to the left or right of it, so you need to know where that is. If you do both those things, graph them, it should come out nice. And there you go.